Welcome to another podcast. In this episode, we're going to be taking a look at how to find the equation of a tangent line at a point. And I have the screen divided into two parts, essentially because I want to look at two different ways of doing this. I'm going to start with what is probably the most basic way to us at this point, and that is that the slope of the tangent line is the slope of the limit of the secant lines. And so, or the limit of the slopes of the secant lines. So that essentially says, and it's what we've been saying, what we've been leading up to this semester, is that the slope of the tangent line at a point is equal to the limit as x approaches the point, in this case the point's A, of the change in y, which is f of x minus f of a, over the change in x, which is x minus a. So this is our tangent formula. I also want to talk about the point slope formula from high school. So if you recall, the line y minus y1 equals mx minus x1. That is what's called the point slope formula of a line, meaning that if you know the point x1, y1, and you know the slope m, then you can form the line through the point x1, y1 with slope m by using that form. So these two things together are going to allow me to find fairly easily the slope of the tangent line as long as I can evaluate the limit. So let's look at an example using this formula. So the example here is, let's let our function be x squared plus 2x minus 3. And I want to find the slope of the tangent line, or I want to find the equation of the tangent line at, let's say, x equal to 1. So what is the tangent line to the curve x squared plus 2x minus 3 at x equal to 1? Well, we're going to start by finding the slope. The slope of the tangent is equal to the limit as x approaches 1 of f of x minus f of 1 over x minus 1. And so if we evaluate f of x, so f of x is x squared plus 2x minus 3. And f at 1, if you plug in 1, you get 1 plus 2 is 3 minus 3 is 0. So you get minus 0 for that piece over x minus 1. And this is a rational expression, so since we're taking the limit, we hope that the numerator will factor, so we can get rid of some terms, and indeed it does. X minus 3 and x, or x minus 1, x plus 3 is the factorization. So you can see that we were able to remove the singularity at 1, leaving us with the limit as x goes to 1 of x plus 3, which that limit is easily calculated to be 4. So we know that the slope of the tangent line at 1 is 4. And so if I use point slope formula, that says that y minus y1 equals the slope, which is 4, times x minus x1. And the question is, what is our y1, what is our x1? Well, the easiest way to see this is I'm at the point x equal to 1, so that's my x1. And the y value is what I got when I evaluated the function at 1, and that turned out to be 0. So applying the point slope formula, the line then is y equals 4x minus 1, or 4x minus 4. And so the equation of the tangent line in this case is 4x minus 4. Essentially what this means is if we were to graph this function, you know that this is a parabola which turns up and passes through the point negative 3. So it turns up. You know that the positive root, x minus 1, occurs at 1. So I'm asking what is the equation of the line that passes through this point. And it seems very reasonable that that line will have an equation of the form 4x minus 4. You can clearly see that the intercept is below negative 3, so negative 4 is the intercept. It passes through 0 when x is 1, because 4 minus 4 is 0. So this seems like the perfectly legitimate line that is the tangent line in this case. Now, I said we were going to look at two ways, and so the second way sort of builds off the first way. if we let x be replaced with the quantity a plus h, then saying the limit as x approaches a is the same as saying the limit as h approaches 0 when x is equal to a plus h, because you could clearly see that as h goes to 0, you get x equal to a. So the limit as x goes to a is equivalent to the limit as h goes to 0 in this case. Because of that, I can take the formula, the limit as x goes to a of f of x minus f of a over x minus a, and I'm simply just going to replace the limit as x goes to a with the limit as h goes to 0. And f of x is f of a plus h, and a is still just a. X minus a is a plus h minus a, but a plus h minus a is just h. So I can clean that up and just call that h. And so the other way to calculate the slope of the tangent line at the point, let's say x equal to a, is by calculating the limit as h goes to 0 of f of a plus h minus f of a all over h. And we're actually going to use that in this next example, because this next example, it's just a little bit easier to evaluate that way. So if I asked you to find the equation of the tangent line to the function square root of x at x equal to 4, then to find the slope of the tangent, I would take the limit as h goes to 0 of f of, see my a value here is 4, so at x equal to a is x equal to 4, so it's 4 plus h minus f at 4 all over h. And if you evaluate those pieces, you get the limit as h goes to 0 of f of 4 plus h is the function f with x replaced with 4 plus h. So it's the square root of 4 plus h minus the function evaluated at 4. Well, square root of 4 is 2. So it's minus 2 all over h. Now, if you try to evaluate that limit directly and try to plug in 0, you get 0 over 0, which is indeterminate. So since there's a square root involved, we're going to try the conjugate once again. So continuing on here, this is the limit as h goes to 0 of, I'm going to multiply the numerator and denominator by the conjugate. When we do that, we will get the limit as h goes to 0. In the numerator, we end up with 4 plus h minus 4. And in the denominator, we end up with h times the conjugate. All right, finishing that out, the numerator, you can see the 4 and negative 4 cancel, which this leaves the limit as h goes to 0 of h in the numerator divided by h times the conjugate. And we're lucky here because the h's cancel. And so if you evaluate this at h equal to 0, it ends up being 1 divided by the square root of 4 is 2, plus 2 is 4. So plugging in h equal to 0 gives us a tangent slope of 1/4. We then use the point slope formula, y minus the, remember this is the y value, y minus 2 equals 1/4 for the slope, x minus the point is 4. And so writing this as a line, algebraically, this turns into 1/4 x plus 1. So if you solve for y and separate out the x, that's the slope of that's the equation of the tangent line that you'll get in this case. So it turns out that this second method that we used is actually the preferred method, because if you tried to evaluate this limit by using this formula that we used on the first problem, then if you had gone that direction, the problem ends up being the limit as x goes to 4 of the square root of x minus 2 over x minus 4, and you would have had to have used the conjugate anyway. So you can't escape using the conjugate here. It just turns out that a lot of times this f of a plus h form is just easier to manipulate. And we're going to see that in some upcoming examples where we calculate the derivative for the first time. All right, thank you for watching.